Please log in your attendance. Yeah. So while you log in your attendance, another 3 of you. Okay, so today we are going to talk about kinematic. So now we know that acceleration is the rate of change of velocity. Am I right? Okay, that is the first fact that we know. So now I want to ask you this question. So if I integrate acceleration with respect to time, so what will I get? What function will I get?
Do you get positive?
Yes, because this is the dv over dt, correct? According to our antiderivative, I will get back my vt function. Then I plus a c. Correct? There must be a constant. Am I right? So that is the first fact. Second fact, what is velocity? Velocity is the rate of change of displacement. Am I right? Okay. So if I integrate velocity function, what function will I obtain? I will obtain a displacement function. Am I right? Then plus a c. Okay. So these two facts that you must know. The third one, is it true that integrate from A to B, Vt dt is the total distance traveled by the object from t equal to A to t equal to B. Okay, someone tell me it's true. Is it 100% true? Is it true for all cases? No. Okay. So if I answer this question, if I say true, if I put the word true, I have to have if. So can you tell me if what? True if
A and B positive.
by the way, A and B are times, definitely positive. So what is the if that I must put down? False. If. Yes. Okay, someone tell me, true if velocity is always positive during this period of time. Okay, let me illustrate to you. This is my velocity function. So it's always positive during this period of time. Correct? False if what? If velocity sometimes is positive and other time is negative. So that means you have a situation like that. Maybe, correct? This is your A and this is your B. And here there is a K here. So in this case, what should I write the total distance traveled? How should I write the total distance traveled? Can someone give me some idea? For the first part, how should I write the limit? Should I write A to K or K to A?
K to
No
A.
answer. Yes, K to A, yes. I should put K at the bottom and A on top so that I turn the negative to become positive. Then I plus K to B VT dt. So every time, so if you look at the textbook, page 138, that is only true. You look at the diagram, that is what they are trying to tell you. So I don't want to follow that. I follow mine. I ask you the question first. Is it true that integral of A to B VT dt is the total distance traveled by an object from t equal to A to t equal to B? So there are two possible answers. So these are called open-ended questions. You say it's true, you give me your condition. You say it's false, you give me the situation. So that means you have full understanding of that. Clear? Okay. So exercise C, 5C, point 1, 5C, point 2, all of you can do because you know how to integrate. So I'm going to discuss one of the question in 5C.3 with you. Can you please turn to 5C.3? Question 2. Okay, 5C.3, page 143, question 2. Okay, can you please use 5 minutes to read through the whole question first? Okay, finish reading. I finished reading already. Okay, this is the velocity function. Part A. The moment you see this word initial, what information does it give you? Yeah, good. The same person answering me. Yeah. Can I just pick someone? Gerald? Gerald? Can you please tell me if the word initial come in, what does that mean? Gerald, are you in my class? Gerald? You see, I have student who just logged into my class and after that he left the class just to make the attendance. Ah, you type to me. Can't you just talk to me straight away?
Here it's raining, here.
Now you talk to me, I can hear what? Gerald, why are you angry of me? You talk to me, I can hear.
No, here it's raining.
But I can hear you. So what is the issue of raining? Gerald? Okay. Initial means starting. So starting, what is the time? When I start something, so T equal to what? Yes. T equal to 0. So that means now I want to find what is the velocity when at the starting. So I put T equal to 0. So it will be 50 minus 10 e to the power of 0. So if you key this into your y1, it will give you 40. Okay? I want to tell someone in your class, you fail your test for SAT2 is because you didn't pay attention in class. We have mentioned so many times the meaning of initial. Am I right? Okay. So you cannot say you are not sure. You have no right to say you are not sure. Do you get me? So initial means t equal to 0. So you want to find the velocity when at the starting point. Okay, find the velocity of the particle after 3 seconds. So you are looking for V3. So you can, if you key this into your Y1, you can straight away call out and you get the answer. Am I right? So this one, I will not give the answer. The answer you can get from the book. Okay, part C. How long will it take for the particle velocity to reach 40? So now, how long means I don't know what is t. But I know velocity is 45. So this is an exponential. If I'm not good at exponential, what can I do? I can sketch this graph. There are a few ways. Am I right? You can go by graph. You key in your y1 as the velocity function. You key in your y2 as 45. So what you need to do? You just do a zoom standard. Then you got your graph. Okay, how is the graph look like? I think the graph look like this. Start from 40. Okay, I can put here as 40, then it go like that. The limit is 50, right? Then you draw, this is your y1. Then this is your y2, which is 45. Then you get the intersection point. Okay, if you don't want, you can use solver. You go to math. Your E1 is your Y1. Your E2 is your 45. Then your X, you put down any value you like. Then you press second. No, not second. Can someone give me the next step that I must do? The next step that I must do? Ashley, can you give me the next step that I must do? Ashley, are you there?
Yeah.
Can you give me the next step using solver? You can get this from Max, huh? Math button. You can get this from Math. After I key in the solver, then what can I do here? What should I do? Like for example, I put it as 3. Then what should I do to get the answer? Can you give me the instruction, please? You see, Ashley, please. Hakim?
Yeah.
Can you hear me?
Enter.
Yes. Alpha, enter. Then you will get the X value will change. Then you get the answer. So you please, I'm here not to provide you with the answer. I'm here to teach you how to get the answer. That is more important than anything else. You want the answer, you can go to the textbook, you can get the answer. I don't want same thing to happen again in your SAT 3. But do you think I have a control of that, Ashley?
No.
No. Who is in control of this? Who is in control?
Yourself.
Yeah. I cannot force you. I can only keep repeating the same thing. So please, so that is part C. Okay, now part D. So please learn up, okay? Please, after this lesson, please go through this. Okay. Discuss VT as T tends toward infinity. Okay, so how are we going to discuss this? Okay, we have done this many times. You'll be surprised. I will turn this question in one of the questions in your exam. Okay, how am I going to discuss this? So I will say as T tends toward infinity. So which term must I talk in the VT function? Which term must I talk?
-0.5.
Yes, I have to talk about this one. Am I right? That involves T. So I have to say what happened to e to the power negative 0.5 T. Okay, Brandon, tell me what happened.
Approaches 0.
Okay, approaches 0, you are right. Okay, so now I can talk about the whole thing. So what happened to VT, which is 50, take away 10 times of 0. It will approach
50.
50. Yeah, from above or from below. This is the upper or lower limit.
Upper limit.
Upper. So if this is the upper limit, then we will say from below. That means the rest of the value is below this value. Clear? As what I shown in this graph. Okay, show that the particle acceleration is always positive. So if I want to show acceleration, what must I do with velocity?
Differentiate.
Yes, I have to differentiate. So differentiate 50, you get 0. Differentiate exponential, you copy down the whole thing. So for this test, you have to be very careful because I can have differentiation and integration come together. So you have to know when differentiating what to do, when integrating what to do. Time by the derivative of the power. So this will be 5 e to the power of negative 0.5 t. So how are we going to prove that it is always positive? We will say t is always greater than or equal to 0. So therefore, e to the power of negative 0.5 t, we know that exponential definitely greater than 0, correct? For whatever value. Yeah, so therefore, acceleration, which is 5 times of a positive number, will be always positive. So this one shown. Are you clear? Are you okay? Okay, so part F. So you know the initial velocity is 40. The limit is 50. And acceleration always positive means your velocity function is always going up. So the curve will look like that. Are you clear? So I don't need GC also, I can do. Okay, then they say, find the total distance traveled in the first 3 seconds. So this one, first 3 seconds. So I have to look for this area. Am I right? So is the whole area above the x-axis? The answer is a yes. So I can integrate from 0 to 3 vt dt. That is in your y1 and you get the answer. The question didn't ask for exact value. You can just use your scientific graphic calculator and get the answer. Are you okay?
Yes.
Okay. So the whole thing is you must know what is kinematic, and very important, this page that we are discussing. Can or not? Hello? So I expect you to read through example 9 by yourself. Since there is an answer, so you read through, you should be able to understand. Okay, so I'm going to discuss question 6 with you on page 144. Okay, page 144. Question 6. Okay, please read through the question. Usually, as I read through the question, I will key the function into the calculator. Please take out your calculator and start to do part A, part B by yourself. If you get stuck in anywhere, please look at the whiteboard. Okay, for B, you can do infinite integral. You can just put here instead of definite. Yeah. And why I can use definite, the reason is because I can straight away put here, the reason is because if you look at because they asked for the distance travel, they didn't ask for displacement, they asked for distance travel. So I can do that. So because the graph for VT, yeah, someone asked about B, yeah. I know the textbook answer is they give you 20/3. Let me explain part B. Okay, your textbook give you the answer STS, indefinite integral of VT dt, right? So then you integrate, you get 20/3 t cubed 2 plus c. Okay. I will say that the textbook answer is because they didn't ask for displacement. They said write a function st for the distance travel. I didn't ask for displacement function. I asked for distance travel. So that means from 0 to t. And I can do that straight away. The reason is because the graph go in this way. It's always above the t-axis. You get what I mean? They are not asking for displacement function. They ask for distance travel. So if I ask for distance travel, this will be the right answer. That's why your part C answer is distance travel You integrate 0 to 2 Vt dt. You got 20 over 3, 2 square root, then power 3. So it will be 40 root 2 over 3 meter. So when you interpret, that means the distance traveled, the total distance traveled in the first 2 seconds. Are you clear? Okay, you get me? So I will find that this is not the proper answer for part B because of the word distance travel, not displacement. Okay. Okay, let's go to part D. Okay, in order to perform his stunt, the motorcyclist need to be traveling at 20 meters per second or faster when he reach the ramp. How long will it take to reach the speed of 20 seconds? So first part, 20 equal to 10 root t. Am I right? So cancel off, 4 equal to t. So you need to run 4 seconds. Okay, so the motorcyclist start his approach 50 meters from the ramp. So now, 4 seconds, huh? So in 4 seconds, how far can he move? So we have to look for the distance travel. Okay, distance travel, huh? So it will be 20 over 3 square root of 4, then cube, right? So you will have 8160 over 3, 552, 53.3. So you only need to travel 53.33. So when he start the approach at 55 meters, so that means the situation is like that. So this is the ramp. So from here to here is 55 meters. So he start here. So he only need to travel 53.33. Then it will reach the velocity of 20 meters per second. So now he's given himself enough distance to reach. Has he? So the answer is a yes. You only need 53.33. So he got 55. So yes, he has given himself enough to reach the speed. So you see, when we solve this type of problem, we will have something to do with integration, something to do with differentiation, and it depends on the scenario. You have to understand the scenario. Are you okay? So please try all the exercises in chapter in 5C. You have 5C.1, 5C.2, 5C.3. Hello?
Yes.
Okay. So if you want, we can try another question on page 142. Okay, that is question 7. That is in 5C.2. This is talking about two animals, okay? So you straight away key into Y1 as, so what you need to do is when you read the question, okay, you read the question first. Then I teach you how to record down orderly. So as you read, you record. So the first one is the lion, am I right? So you write down lion. Okay, lion is you key into Y1. So the is 15 e to the power of negative 0.1 t. Okay, then the second one is the zebra. So you record down nicely. So that one you will key into your Y2. That is your V2. 20 minus 20 e to the power of negative 0.1 t. Okay, now, if you have a look at this, so what we will do is, they ask you, find the speed of each animal after 1 second. So that one should be simple enough. Show that the lion's speed decreasing over time, whereas the zebra speed increasing over time. So how are you going to do that? Still remember how are we going to talk about increasing speed and decreasing speed? Can someone suggest to me what two sign diagram must I have?
Velocity and acceleration.
Okay, so now velocity and acceleration. So to do part B, so part A, I'm not going to do, you should be able to do. Okay, part B, I'm going to do for lion. Okay, the V1 sign diagram. So you see, it's always positive. Am I right? There is no turning point. Okay, V2, AA, 1T. So what should I do? So I put my AT, A1T as, I differentiate it. Right? So it will be negative 1.5 e to the power negative 0.1 t, which is always negative. Yeah, so negative. So you will say velocity is always positive and acceleration is always negative. Therefore, the speed is always decreasing. Yeah, over time. So you can use this to show for this case. Okay, then I do for zebra. Okay, same thing, the zebra. Okay, now, as t tends toward infinity, it will be positive, am I right? So, velocity is always positive. Then the acceleration for zebra. So how you differentiate? 0 minus 20 e to the power negative 0.1 t times negative 0.1. So you got 2 e to the power negative 0.1 t is always greater than 0. So the zebra always move to the right with a positive acceleration. So therefore, the speed is always increasing. Done. Can or not? Then they ask you to find 0 to 3. Okay, now you want to learn how to interpret. What you need to do is, usually I will draw the graph first for both. I will sketch the graph for both VT and AT. Y1 and Y2. So the Y1 graph is start from 15, right? When t equal to 0, it is 15. So I can draw my graph like that. Then after that, it go up. No, it should be go down. So mine is wrong. The way I draw the axis, can I sketch the graph? Okay, may I know? Okay, from here, instead of tell you where I go wrong. Can anyone tell me what is the lowest possible value for, what is the highest value for the speed of the velocity of the lion? The graph should go up or go down? Hello? The graph for velocity of lion, should it go up or go down?
Go down.
Okay, why go down?
Because the AT is negative.
Yeah, because the rate of change of velocity is negative. So if I sketch the graph like that, how am I going to draw the graph? So where should I put my t-axis? My t-axis is here. Where should I put my 15? Hello? Where should I put my 15? Yeah? Someone answer me through that one. Okay, I'm going to call someone to give me. Queen. Just how I put my 15 here, correct or wrong? I put my 15 here. Good or bad?
Wrong.
Wrong. So where should I put my 15? Higher or lower?
Higher.
Higher. Thank you. So I cannot put my 15 here. I have to put the 15 higher. I have to put it here, 15. Then the graph go down. Am I right? So this is your V1T. This is for the lion. Okay, how about the zebra? How about the zebra? So it's going up, correct? But is there an upper limit? There is an upper limit. The upper limit is 20, correct? So I'm going to draw for the zebra. The zebra start from 0. Am I right? When t equal to 0, y2 is 20 minus 20 e to the power 0. So it's 20 minus 20, so it's 0. So it start from 0, it go up. The upper limit is 20. So this is the V2. So there is an intersection point here. Right? So I have the visual first. So I continue with my part C. So if I integrate, from 0 to 3 V1t dt, I'm referring to this area. So what does this area represent? The total distance traveled by the lion in the first 3 seconds. Okay? Then what does the 0 to 3? What does this represent? This one is this area, correct? And this part this area will be this one. Am I right? So what is the meaning of this whole thing? It will be the difference between the total distance traveled by the lion and the zebra. Am I right? Can someone tell me what is the point of intersection? Yeah. Use your GC and tell me the point of intersection, please.
5.596.
What is the answer?
Actually,
Again?
5.596.
5.
Yeah.
5.596. Okay, so that means 3 is here. Right? Are you okay? So explain why the lion will be closest to the zebra when V1t equal to V2t. How to explain that? Okay, I'm not going to drag you. I will continue this afterward. Can or not? I'll continue with this one the next lesson. We are going to explain that. Okay, because I believe some of you all got other class to go. Okay, so thank you, class.
Thank you, Miss.
Yes.
Yeah.
Yes.